Okay, let's get started. In the first question, we can say that x and y are independent with x is equal to this x minus 1 minus u of x minus 2. So we can draw f of x 1 to 2. This is 1. And f of y is given by equal to u of y minus u of y minus 1. So we can draw f of y like this, 0 to 1. This is 1. So first, we use the convolution method. We can see f of z is equal to the integration from minus infinity to positive infinity, f of x alpha, f of y z minus alpha d alpha. This is equal to the integration from minus infinity to positive infinity, f of alpha is equal to u alpha minus 1 minus u of alpha minus 2 times f of y z minus alpha. This is equal to u of we change all of the y in f of y into z minus alpha. This is z minus alpha minus u of z minus alpha minus 1 d alpha. So this is equal to the integration of u alpha minus 1 times u z minus alpha, these two terms, and minus u, these two terms, is equal to u alpha minus 2 times u z minus alpha, and these two terms is equal to minus u alpha minus 1 times u z minus alpha minus 1, and these two terms is equal to plus u alpha minus 2 times u z minus alpha minus 1 d alpha. So we have this is equal to the first term is equal to the integration from 1 to z, and d alpha u, because when z is less than or equal to 1, this term should be 0, so z minus 1 times the step function. So the second term is oh no, this is minus. Second term is 2 and z. From 2 to z, d alpha, this is 1, and this is 1 inside, u z minus 2 minus, this is 1 to z minus 1. So 1 to z minus 1, 1 inside, d alpha u of z minus 2, and plus the last term is equal to 2 to z minus 1, 2 to z minus 1, 1 inside the alpha u z minus 3. So we can plus them all. Oh no, add them all. Sorry. This is z minus 1 times u z minus 1 minus z minus 2 times z minus 2 u z minus 2, these two terms, and this is equal to z minus 3 u of z minus 3. So we got the f of z. We can write it in this form. When z is between 0 and between 1 and 2, it is z minus 1. And when z is between 2 and 3, it is equal to z minus z plus 3, because it's this term plus this term. It's z minus 1 minus 2 z minus 2. This is minus z plus 3. And else 0. We can draw f of z. F of z is equal to z minus 1 between 1 and 2. 1, 2, 3, 1, 2, 3, z minus 2, and minus z plus 3, like this. Okay, now let's use the geometric method to solve this problem. We can draw f of because x is between 1 and 2. Otherwise, it will be 0. And y is between 0 and 1. So we got this shade area. This is our okay. Let's solve this problem by the geometric method. We know that f of x, in f of x is between 1 and 2. Otherwise, x will be 0. So this is 1, this is 2, this is x, and this is y. And in f of y is equal to, y is between 0 and 1, and others it will be 0. So we got this shaded area. So z is equal to x plus y. So we can draw a line of y is equal to minus x plus z. It will be like this. this is y is equal to minus x plus z. So we will split it in different situations. The first situation is when z is less than or equal to 1. We have f of x, y, no, f of z. Write this when z is less than 1, we have f of z is equal to the probability of x plus y less than or equal to z. That is the area of this area. That should be 0, because none of this area is inside of the shade area, which x and y have values. And when second situation, when z is between 1 and 2, the line should be drawn like this. So now we have f of z is equal to this shaded area. We got that this is equal to y is from 1 to y is from 0, y is from 0 to this point. Y is equal to x is equal to 1, and y is equal to z minus 1. Y is from 0 to z minus 1, and x is equal to 1 to this point. This point is z minus y. Z minus y. The inside is equal to 1 dx dy. So we have this is equal to z minus y minus 1 from 0 to z minus 1 dy is equal to z minus 1 times z minus 1 and minus z minus 1 square. So this term is equal to z minus 1 square plus 2 this is equal to half of z square minus z plus 1 over 2. And the third situation is when z is between 2 and 3. We have, let's draw it again. This is the shaded area, 1, 2. So the line should be like this. This is y equal to minus x plus z. This is x, this is y. So we have f of z is equal to p of x plus y less than or equal to z. It should be this area. So we have that it's equal to the total probability 1 minus this little shade area. This is equal to let's compute it. So we know this point y is equal x is equal to 2 and y is equal to minus z minus 2. Z minus 2, this is y is equal to 1. 1 minus z minus 2 is 1 minus z minus 2. We got 3 minus z. So this length is z minus 3. And 3 minus z. And this is equal to this length. So we got that this is half of 3 minus z squared. So we got f of z is equal to minus 1 over 2 z squared plus 3z, 3 times z minus 7 over 2. So, and when the last situation is when z is larger than or is equal to 3, we got it should be like this. So we know that all of the shade area is inside of this bigger shade area. So this probability will be 1. So f of z is equal to p of x plus y is less than or equal to z. So this probability is this larger shade area. That totally includes this smaller shade area. So we got this is equal to 1. So in conclusion, we have f of z. The CDF of z is equal to 0 when z is less than 1. When z is between 1 and 2, it will be 1 over 2z squared minus z plus 1 over 2. When z is between 2 and 3, we got it's equal to minus 1 over 2 z squared minus 3z plus 3z and minus 7 over 2. And else no, z larger than or equal to 3. So we have the PDF of z of this joint. The joint PDF is equal to the differentiation of the CDF of this the joint CDF. So it's equal to when z is between 1 and 2 is equal to z minus 1, and when z is between 2 and 3 is equal to minus z plus 3, and else it will be 0. This is totally the same with the former joint PDF. We got to use the geometry. No. This is totally the same with the result. We got use the convolution method. This is z, f of z. This is 1, 2, 3. Okay, that's finished.